All right. Good morning, everyone that is watching me from home, from office, from school, from different places all over the world. So you are welcome to Seeds of Wisdom Tutor. So my name is Joshua Family. I'm greeting everyone Happy New Year from this end. So today, without wasting much of our time, we are looking at heat measurements. That is physics. Okay, let me write it. Physics. Yes. Heat measurements. There are some terminologies we use when we come to heat measurements, and we have mode of heat transfer. Though I won't be focused on the reading aspect of it, I will focus mainly on the calculation aspect. But I think there is a need for me to explain where we are coming from before I just jump to calculation. We have mode of heat transfer, which is conduction, convection, radiation, and advection. So we ought to know that conduction happens in a solid form. It is heat transfer that occurs in a solid substance or material, while convection can occur both in solid or in a liquid form, and the radiation has to do with black bodies. And we have sun, has to do with sun, and we have black body as a good absorber. We have white color or sleeping color as a good reflector of heat. And also, when it comes to heat measurements, there are some terminologies we need to talk about. We have the heat capacity, specific heat capacity, specific latent heat of fusion of ice, and specific latent heat of vaporization, that is of steam. So specific heat capacity may be defined as the heat required to raise a specific 1 kilogram with a temperature in Kelvin. So different materials require different heats to melt or to change a state of matter. But as I said, that we are going to be looking at the calculation aspect of it mostly. So the first question, we have two quizzes on the board. The first question we have is, what is the quantity of heat required to raise the temperature of 300 grams of aluminium cube from 30 degrees Celsius to 70 degrees Celsius, given our specific heat capacity of aluminium to be 900 joule per kilogram per Kelvin? Yes. And as this topic is concerned, I can say it's revolving around three formula. So the formula that we apply to this is Q equal to MC delta theta. Yes, Q equal to MC delta theta. So where Q is the quantity of heat required, M is the mass of the substances, C is the specific heat capacity, and delta theta is change in temperature. Yes, it's change in temperature. So let's start for the first question. We have been given let's write the parameter M equal to 300 grams, and then we have the theta 1 to be 30 degrees Celsius, and our theta 2 to be what? 70 degrees Celsius. Also, and then we have the specific heat capacity of aluminium to be equal to 900 joule per kilogram per Kelvin. Yes, per kilogram per Kelvin. So having all this, just substitute all these parameters to the formula given. But one thing we must take note that we are given our mass in gram. There is a need for us to change from gram to kilogram. So changing this from gram to kilogram is divided by 1000. We have it to be equal to 0.3 kilogram. So let's substitute. Our Q equal to 0.3 times 900 times open bracket 70 minus 30. I believe that you know the meaning of delta theta is change in temperature. So we have to subtract the higher temperature from the what? From the lowest, or sorry, to subtract the lowest temperature from the highest temperature. So we have Q equal to 0.3 times 900 times 70 minus 30 is 40. Then Q equal to, that is our final answer should be, let me check here. We have 0, okay, we come in, divided by 2 times 900 times 40. So final answer is 10,800. 10,800. So after you get your final answer, don't forget to put your units. The units of it is measured in joule. So joule is the final answer. So if you want to put your answer in standard form, you can do it. If you want to put it in kilojoule, in megajoule, in picojoule, so you can see apply it. So this is the final answer for this question on the board for quiz number 1. So let's quickly move to quiz number 2. Quiz number 2. Before I go there, I must explain that you see this particular Q that we call quantities of heat also has its own formula. If you still remember from Faraday's laws of electrolysis, that we said that Q equals to, okay, let me use this marker, color blue. Q equal to IT. That is, to get the quantity of heat equals to what? Current times time. So the question on the board for quiz number 2 is an electric heater rated 15 volts, 40 watts, fitted into a metal block supplies heat to the block of mass 1.5 gram. So let's start by writing out our parameter. So we have 15 volts, 40 watts. Power is measured in watts. This is calculated, our potential difference is what? 15 volts. So our power equal to 40 watts. And also we now have a mass M equal to 1.5 kilogram and specific heat capacity of 460 joule per kilogram per Kelvin. XHC equal to 460 joule per kilogram per Kelvin. And also what next? Now calculate the temperature rise in the block if the current flows for 10 minutes. So the current flows in the heater for 10 minutes. So time equal to 10 minutes. So there are some things that we also need to change. You know, by the time you want to calculate the first question, we convert our mass from gram to kilogram. So likewise here, you cannot use your time in minutes. There is a need for you to convert your time to seconds. So when we have 10 minutes here, if you want to convert to seconds, just multiply 60. 60 seconds make 1 minute, and 60 minutes make 1 hour. So to get our minute, just say 60 times 10. That will give us 600 seconds. So equal to 600 seconds. And then we now have our power. So if I'm coming from the formula that says our Q, let me use the blue marker. Q equal to MC delta theta. So here we have to look for change in temperature. So for us to get our change in temperature, and I said that we call from Faraday's law of electrolysis that the quantity of heat required is equal to current times time, and we have been given our, but P equal to what? IV. So let's make that equal to IVT. So our Q will now be equal to what? IVT. So substitute IVT equal to this. So we have IVT equal to MC delta theta. And the question says that we should calculate change in temperature, of which that is our what? Delta theta. So let's say divide both sides by what? MC. So MC cancel out MC. So our change in temperature equal to IVT upon MC. So the next thing just was to substitute our parameter. So our change in temperature equal to our IVT now. We have, so you know that IV is equivalent to power. So just bring out your 40 multiplied by our time has been converted to seconds, multiplied by 600 over our MC now. Mass is 1.5. 1.5 times the specific heat capacity is 460. 460. So by the time you do the calculation, our change in temperature, which is our final answer, will be equal to, let's calculate. You can press your machine, your calculator. So we have 14 multiplied by 600, then divided by, okay, we have, let me write it out. We have delta theta equal to 24,000 over 460 multiplied by 1.5. So that is 690. If you love, you can cancel out, or if you like, you can divide direct. So our change in temperature equal to, that will be our final answer, 24,000 divided by 690. So our final answer is 34.7. So change in temperature equal to 35 degrees Celsius. So that is our final answer. I believe with this little explanation of mine, you have get how to calculate heat measurement, either given the temperature, or you have to calculate the temperature to calculate the specific heat capacity, or to calculate the mass. You knowing this formula will be easy for you. Just do the change of the subject of the formula, then you get your final answer. See you next class.